So when we left off last time, we had this arena model for the outpatient clinic scheduling, and we were looking at different allocations of patient appointment times. So if we had patients all arrive in a double booking strategy and our arrival time being every 20 minutes versus, say, single booking every 10 minutes, and then also narrowing the gap between appointments or having all the patients come all at once in a similar pattern for 48 patients. So we wanted to look at some questions where we want to be able to take the output from these experiments and look at the results. So what do our results tell us about different scheduling conditions, and what simplifying assumptions have we made? So just to look at some of these results, here I've filled out the solutions in terms of the maximum time of the clinic, average utilization of the doctor resource, where we have 2 doctors, and average time in the system, total time in the system for the patients, and average wait time in the system. So we can see that double booking versus single booking over that same 20-minute per 2 patients time period, the double booking leads to slightly longer average time in the system due to a bit of waiting time, so 2 2/3 minutes or waiting time. When we narrow the gap between the patient arrival times, so we shorten the length of the clinic to a little over 3 hours versus almost 5.5 hours, the doctor utilization goes up, which we would expect, and which is probably desired by the doctor resource. The total time in the system increases by about 8 minutes or so, and the majority of that is down to wait time increasing. So the question would be, is this a reasonable amount of time to wait? And then when we have everyone arrive at once, the time of the clinic stays about the same. So this would suggest that spacing the patients on average 5 minutes apart is about right. We're not having a lot of scenarios where the doctor or the nurses are waiting for people. But the average total time in the system on average is 99 minutes versus 22 to 24 minutes. And that just means that there's a lot of waiting time going on. So through this experiment, we can see, okay, well, we definitely know that that's not a great strategy for the patients. And it's also showing us that the strategies 3 and 4 that we've looked at are probably about right, because we're not going to increase the utilization of the doctor, and we're not lengthening the time of the clinic by too much compared to the worst case scenario for the patients here. When we increase the number of patients, again, we can see how these strategies play out. We'd probably want to further reduce the time between patients' arrivals for these 2 strategies here, just to see if we could get some more improvement in terms of utilization while not having too much wait time for these patients. So thinking back about what assumptions we've made, well, we've assumed that all of the patients are going to arrive as scheduled. That's probably not going to happen in reality. What other assumptions can you think about? So think about this. We'll talk some more about this example when we meet next time. So other things to know about ARENA: all modules and entities and entity types and resources must have unique names. We'll talk a little bit more about this on the next slide. The batch run, no animation setting is a good option when you're running many replications or long simulations, or you've already used animation to work out any kinks in your modeling strategy. So you can go to run control, and then click batch run, no animation in ARENA. We've talked a little bit about the number of replications under run setup that we should use. Generally, I've just told you type in 10 replications, and then we haven't really said why, besides the fact that we do need more than 1 replication in order to look at the variability and outcomes when we use different random number streams. One strategy you can use to determine what this number of replications should be is take a particular outcome of interest that you have and think about what desired half width you'd want to have. And so if you want to measure the time that patients spend waiting within 3 minutes, then you could set that as your outcome of interest half width, and then see what number of replications would get you to that particular half width. So that's one strategy people use to make this decision and justify the decision of the number of replications. So going back to unique names, in addition to having unique names, you need to avoid names that are in use by ARENA. So there are protected terms that ARENA has, such as RN is a random normal in ARENA. So if you're modeling a nurse as a resource, you wouldn't be able to abbreviate this as RN. Here are some other protected terms. So ER, for example, you wouldn't be able to use if you're modeling an emergency room, because that's a protected term in ARENA so that it knows how to use Erlang. All right. So then if we have the two concepts of terminating versus steady state simulation, we talked about this a little bit, but let's go into a little more detail here. If you have a simulation that starts at a defined time in a defined state and ends when some other criteria of state or time is met, then that would be a terminating simulation. So for instance, an outpatient clinic might be open at 8 a.m. and close at 5 p.m. or close at 6 p.m., whatever it is. That would be a terminating simulation. It has a defined start and end to it. If you have a non-terminating or steady state simulation that just continues in perpetuity, then you would want to analyze the steady state behavior of that system. If you started analyzing behavior from when you started it and it was started as an empty system, then adding the statistics into your analysis from the part where it was empty or not yet fully at steady state might bias your findings. So you, the modeler, would need to determine the suitable length of time to run the model and warm up the system, and then only start collecting statistics on your system after a certain warm-up time has occurred. So you can study the behavior of the system over time using dynamic plots, so knowing, when the average length time patients spend waiting is after one entity versus after 10 entities, after 100 entities, kind of look at how that changes over time. And then only start collecting certain characteristics, or all the characteristics about your system once that warm-up period that you determine has elapsed. One example of a steady-state system that we talk about a lot is an ED. In the emergency department, it never closes, so there's no real start and stop time for that system. Okay, so speaking of dynamic plots, we can add these to our simulation model in ARENA to see our how things change as our simulation progresses. So it gives you a little bit more information than just the summary statistics at the end of running a model. So in ARENA, you're going to use the plot button to initiate a dynamic plot. You click on the data series tab and you click add, and then you can give a name and create the expression for the plot, or type in your own expression that you want to plot. All right, so let's go over to ARENA and let's look at our model here. So we want to build a dynamic plot for our doctor. Let's see the number of doctors that are busy. So we're going to create a data series. So we'll click add. I'm going to give this a name, doctors busy. And so we want to build expression. Click on the drop down, click build expression. And we're trying to plot the number of doctors that are busy, so we're going to go to resource, usage, current number busy. So over time, as the simulation model runs, it will plot the current number busy. You choose the resource that you want to model. Here, I'm just going to use doctor. So this will say NR of doctor. So that's the current number of busy the doctors, your resource. Okay, so then we want to go back to our slides here. We can click on the Axes tab, change the scale properties for the left y-axis and the time axis, the x-axis, and we're going to remove the y-axis. So for the scale, we can define the min, max, and major increments, and you may want to turn off your auto scale for both x and y axes. Okay, so click on the Axes tab, remove the right y-axis, and this will give you an idea of what your plot is going to look like down here. So under x-axis, we can change the time. We are using minutes as our unit of time for the simulation, so that's what it's going to print out in. So under run control, we set it as minutes. And we said we were going to run this over 10 hours, so that would be 600 minutes. And so for that, I'm just going to set this to 1 hour length time for the major increments, so 60. Every 60 minutes, it's going to have an increment. So here you can see this is that represents the 10-hour periods. I'm just going to set the auto scrolls to false. Okay, and then we'll click on the y-axis next to set the major, minor increments, and min and max. So if we're thinking about what we're plotting, this is the number of doctors busy. We have at most 2 doctors that can be busy at a time. So I'll just set the max value, to 3, so that we can see 1 and 2 clearly, and the major increment to 1. What's it doing here? So we've got the minimum of 0. Oops. Alright, so the reason this is looking funny on our preview here is sorry, for some reason that didn't set correctly, so we're going to get rid of the auto scroll. And now we see 0, 1, 2, 3. Okay, so you can press OK. When you press OK for the first time, it'll allow you to click and then drag out and define the size of your dynamic plot. All right, so now let's run the model, and we can watch the dynamic plot appear here when the doctors are busy. So we've got these patients. It's going from 0 to 1 to 2, back to 1 and 0 in terms of the number of doctors that are busy. So we can watch how these plots change over time. And here I think, let's check out my run setup. Here the terminating condition was 32, so that's why we see patients ending around this part of the day, not the full 10 hours. Okay, so this is the next topic we're going to look at is resource animation. So when you're verifying a model, it's helpful sometimes to see when the resources are busy and who they're working on, and make sure they're working as intended. So the resource animation can give you a clear signal as to when a resource is in use by having a different picture for an idle versus busy resource. So we can choose an identifier such as the doctor for our resource and open the workers picture library or the people pictures library and define our pictures based on these. So they should be installed in Arena. This path actually is not where my Mersal stored. So if you search your computer or the computer in the classroom that you're working with for people.plb or workers.plb, it'll show you exactly what that path should be. And then you would want to change the idle picture. So click on idle on the left side and select from the picture library that a doctor that looks like it's idle, transfer this using the double left arrow, and then repeat the process for the busy picture with a doctor that looks like it's busy. You can also choose to have a seize area for the resource so that the entity that's using the or seizing the resource will appear in the seize area. So that person will appear in front of the doctor in the seize area. Then you would click OK and place the doctor on the screen above the process module for the doctor. And you can always edit this to re-choose idle and busy images. So let's go ahead and walk through this in Arena. So we want to animate the doctor. So first we're going to click on our animation button here for the resource. And I've already pulled up my library, but I'll just show you open. Mine was in picture libraries under the path here. I'll just show you. So it's under C, users, public documents, Rockwell software, which is creator of Arena, and then picture libraries. So you can see here all the different picture libraries that are available. We're already in People PLB, so I'm going to leave it there. And first, we'll click Doctor, and we're going to change the picture for the state of idle. So I'll scroll down to one that maybe looks like an idle doctor. Let's see, where was that? You can use anything here. This is a doctor looking person that doesn't have anything in their hand. And then here's a doctor with blue pants and raising their hand holding something. So looks a little busier than this idle doctor. But use whichever picture you want. And then I'll click the seize area box and then click OK. Again, we're going to drag out our picture, click, and then in this one it just clicks once, and then you can drag the size out. So this is the seize area for the doctor, this little round dot circle here. And so when we press play this time, the people that are being seized by the doctor will appear here, and this is the idle picture of the doctor, and the busy picture will change to the doctor with blue pants raising his hand. Let me just slow this down a little bit so you can see. We do have two doctors in this scenario, so we do have two resources available. Right now, we're only modeling whether either doctor was busy, so it doesn't distinguish in the picture between one or two being busy. There is a way to do this, but it's a little beyond the scope of what we're going to do in this class. Alright, so now we can see if that's working appropriately. Alright, so now we're going to go back into detail with the record modules and go through step by step each of the options that we can use with the record module. So first, the count option maintains a count of the prescribed increment or decrement, positive or negative, that you tell it. So the increment may be defined as expression, a function, or just any real value such as 1, which is the most common thing you'd want to use. And this value changes every time an entity enters the record module that you've set up. So if you wanted to count the number of admitted patients versus the number of discharged patients that are going different directions out of the ED, say, then you would place a record module under each arm, give it a name for what you're trying to record, select the type of count, and the value that you'd want to increment by would just be 1 for each side. And then the counter name is what's going to appear in your output. So you just want to set that so that it's something meaningful to you to know where to look for the output in your files at the end of the simulation run. The next type of record module is the time interval. So we've talked about this a little bit, where we look at the difference between the current time and the time stored previously for the attribute when it entered the system. So this can be used to collect the total time in the system. Again, you want to have an assign module at the beginning that assigns that the time entered the ED, say in this example, was T now. And then when you go to have the record module with the type of time interval, the attribute name that you refer back to would be time entered ED, and that would be available from the dropdown. And then you want to give a tally name for the time in the ED for that particular type of patient. And here, in this chart, we've got low risk and high risk patient because this was done for each type of patient. Then the time between option is going to tally the time interval between two consecutive entries of entities in the record module. So this is basically the enter departure time from the module. The reciprocal of the mean enter departure time is going to give you the model's throughput, just like we talked about with queuing theory. So that's why you would want to potentially use the time between. So here, an example would be time between after a nurse. So this is for the module after seeing the nurse. You could set up a record module to calculate the time between and look at the throughput of that system. All right, and then finally for the record module, you could use entity statistic type to collect anything about time and costing duration information, or the expression option for tallies of any type of expression that you could dream up. So it just offers a lot of flexibility. So now we want to look at modeling queues with other queuing disciplines other than first in, first out / FIFO. So you can go back to Arena and click on the spreadsheet icon queue under basic process. And you can select the desired queuing discipline of the ones we talked about, LIFO, FIFO, and some priority queue. So this is based on lowest or highest attribute value. So you would use the assign module to set an attribute value prior to the patient or the customer entering the queue of interest. So if you had patients that were queuing for a doctor that had low risk patients and high risk patients, you'd have the high risk patients have a higher attribute value, and then you could choose the queuing discipline to be highest attribute value. So just to show you how this works, in Arena you have your queue. So for the meet with doctor queue, you would be able to set this based on the attribute value. All right. Going back to our slides. The last thing we want to talk about here would be sets. So a set is a group of resources. So we want to click on the set spreadsheet icon under basic processes. So in class we talked briefly about, okay, what if you had a doctor named Dr. 1 and a doctor named Dr. 2 versus having two available resources of just the type doctor. So here with Dr. 1 versus Dr. 2, we can distinguish between the doctors a little bit easy, or we can distinguish now between the doctors versus having two identical doctors. The way you do this is go to the set basic process spreadsheet button, double click to add a new row to add a new set, and then click on 0 rows to add a desired number of members to the set and give each member a name. And then you could, once you've set up the set, you can then change your resource use under that. So let's take a minute and set up this set, and then we can, I'll show you how you use a set for the resource. So in Arena, we're going to double click to add a new set, and we're going to call this set doctors. Set. It's a type of resource, and we'll click on 0s and then double click to add two doctors. And I'm just going to call them Dr. 1, Dr. 2. You can use whatever fun names you can think of. Alright. And so we've got the 2 rows representing the 2 sets. So now we're going to go into the Meet with Doctor and edit this. And now instead of the type of resource being a resource, we're going to select a type being the set. We've already created the set, so we'll click on the set that's in the drop-down menu. The quantity that we want to select for our resource is still just one. We only want one doctor in this process module. We only need the one doctor. So then, right now we'll just select cyclical. But the different ones you can select would be cyclical, where it goes in some pattern. Random, it's going to randomly choose who to select next. Preferred order, you can have it always select Doctor 1 first and then Doctor 2. Then specific member is going to be useful for when we want to visit the same doctor or other resource when we have a follow-up process module. So in the first process module, you would use the member that you want to use again later. You would save that member by specifying a name under Save Attribute, something like Doctor Used or Doctor Seen, so that we can then refer to them later using specific member. You can also use smallest number busy or largest remaining capacity. So there's a bunch of different selection rules. So going back to the arena, we're going to use cyclical, and then I'll write the attribute name as Doctor Seen. Click OK. Right. And let's say that we want to add in another process module here at the end, where let's meet with doctor again. Again, we're going to have a seize delay release of the doctor. We're going to have a type of the resource be set. Let's use doctor set. Still, we'll just want the quantity of one doctor. And this time, instead of cyclical, we're going to use a specific member because we want to see the same doctor. And then when we click the set index, it'll already have on our list the attribute we just defined of Doctor Seen. And click OK. And maybe this is just a short check-in, so we've got triangular in minutes, 1.5, 1, and 1.5. Click OK. And now, when the patients go through, they're going to see a particular doctor and then back to that same doctor here. All right. Next, you can give it a try on this module where we have a set of nurses, cyclical selection. Patients are going to arrive according to this exponential distribution. See, they'll get their flu shot with one of the two nurses using that cyclical selection. Have 25% of the patients wait for 20 minutes, and then for the patients who waited, the same nurse will check them out before they leave with a constant delay of 1 minute. So here we'll use that specific member choice. So go ahead and try running this model, and we'll revisit this when we meet next time.